Hello everybody, and welcome to the YouTube Model Builders Arduino Workshop Show with Chris and guest. I want to say go to YouTubeModelBuilders.com. There you can find the schedules for all the shows. Tuesday and Wednesday shows are at 8 o'clock Central, 9 o'clock Eastern Time. The Thursday night show and the Saturday shows are at 9 o'clock Eastern, 9 o'clock Central, 10 o'clock Eastern Time. Also, be sure to click on the e-magazine and sign up for an email notification when it comes out. November was the last issue for 2017, and that one was on N-scale. So I have a new one coming out in January. Alright, so tonight's show is going to be really interesting. Chris has got a guest on that's been here before, and I'm going to turn it over to him, let him introduce his guest, and we'll get this show rocking and rolling here. So Chris, it's all yours.
Alright, thanks Johnny. Welcome back everybody. It's been a while. I know it's only been a month, but it seems for some reason, because the way the calendar fell, feels like it's been about 6 weeks at least, doesn't it? But anyways, tonight we're going to hit a topic that had a lot of interest in turntables. And I've got a special guest, Greg Hines. He's been on before. He showed us a few months ago his prototype that he was starting to work on. Well, he's gone quite a long ways with it. It's really impressive. So tonight we're going to let him kind of show off where he's at and then go back the beginning, and he'll kind of show us his code and how he started to develop it, because you know, anybody who's interested in actually trying to start making one, this will give you some good places to start. I think it's a little too elaborate of a project for us to try and make one hands-on, but I think this will give us some great ideas on what we can do if we want, and we could even maybe try making a simpler version in the future if there's enough interest. So with that, I'm going to turn it over to our good friend Greg and let him start explaining what he did, and then we'll jump back in a few minutes and just kind of look at some of the basics once we see what he did. So, Greg, it's all you. Thanks.
Thank you, Chris. We started with, I'm going to pull this back here and we'll see. This is the original concept, turntable stepper, and we have now evolved into this new design here with the actual turntable bridge, mounting mechanism underneath. My good friend out of the UK actually laser cut this housing for the stepper motor, and from a plan that I actually found online that I liked, and he did a good job with that, and then I modified it to fit my motor and some of the special hardware, and we can go into that more. I've also upgraded from an Uno to a Mega with all the added software. I've run out of memory out of the Uno, and so I've had to make some changes. I've also upgraded and made a custom board that shield here that we can use either on the Uno or the Mega.
Yeah, that's really cool. I was looking at that the other night, and you know, he actually did the design for that board and had it made.
So I used OshPark to actually do the printing of that board, and so that worked out pretty well.
Is there any possibility that for OshPark that you could make that board design public so other people can order them?
Well, I've been tossing around selling them, but yes, I could do that. We'll have to see how that goes.
If you sell them, that's fine too.
And granted, that's the one for the Uno, which is, you know, no longer relevant for his project, but I think he said he was working on one for the Mega too.
Yeah, I mean, this board adapts to to a Mega with just 2 jumper wires. So I mean, it's very easily to take it. I can actually show you what this whole thing looks like here with the Mega. Let's get the camera focused in here. So the custom board here with the Mega right here. Let's see. And then the Fram for recording all the locations of all the stubs. I have plug-in here for that I still need to make up for the keypad. The sensor board plug-in, the I2C bus for extensions, and onboard reset switch. And then this cable here is for I2C on the Arduino. That's the orange and yellow wires there. They've moved them off the Arduino to a much higher pin set on the Mega, so which I didn't know when I made the board. Otherwise, I probably would have put in a plug jack there for that as well. So that's where we are right now. And you guys on the last show was asking for an LCD screen. So guess what I made up for you guys. Let's see if I can get this to show up tonight. Yeah. I'll see if I can get this set up so we can see both here. The screen is so bright, it's hard to see it sometimes.
Oh, there you go.
Almost.
There. Won't see the turntable, but
yeah, well, we'll get that figured out there. Yeah, it's iffy. Let me see if I can zoom back a little bit. There we go.
There, that's good.
So I'm also using a keypad. Last year we were using membrane keyboard. I really like this one a lot better. Good tactile touching on it, and good feedback. It seems very responsive. The film keyboard didn't seem to work as well as this does. We can go through here, and I'm just gonna, right now on the screen it tells you the number of stubs. It's between 0 and 2, which means we have a total of 3 stubs there, and we can choose either end. This turntable has a side plate for a gear shift, and that's what I've chosen to be my front end of the bridge, and the opposite end is the back end of the bridge. And the front end is denoted with the star, and the back end is denoted as the pound. And so we can move to stub number 1's front, and we'll just spin it around, and it will tell you the status of the turntable is either moving or it's idle. You can go to 2. You can rotate it the back end through.
So how do you know which is the back end? I mean, other than the pound and the star, how do you hit something other than 0 on the keypad?
So I hit 0 on the keyboard, and then I hit the pound sign if I want the back end of the bridge, or I hit the 0 in the star for the front end of the bridge. Gotcha. So you can select either end, and it will find the shortest path for rotation, and it'll go either one way or the other.
Very nice.
So last time we also, I was running a separate program to reflash the the system. I've now built that in so that you can reflash all the locations. And first you got to put it into programming mode by holding the star key. It then resets the bridge and finds the 0 location of the stepper motor that I have with a sensor underneath the bridge. And once it finds that,
what
go
kind
ahead.
of sensor are you using?
It's just an infrared beam sensor. That one that you can use, that you can buy online pre-built for 3D printer, very easily hooked right in.
So what's the accuracy? Must be pretty tight then if it's for a 3D printer. Huh?
It's just this. It would very similar to what you were using for the speed test.
Okay.
Type of deal. Just a 3-wire power ground, and then it's either a high or low sensor. So. Right,
but the beam wise, the repeatable accuracy, is it within thousandths? So stopping in the same thousandths of an inch, or.
I gotta think it's pretty close. I'm using just a regular screw to break the beam. I suppose if you had something a little thinner, it might be a little bit more touchy, but the screw gives me a little bit of flexibility for moving it in and out and up and down to break that beam.
So how do you plan on mounting that in a layout then with that end stop? Like, so it doesn't interfere with the bridge. Is the screw set up into the bridge so that it doesn't interfere as it turns?
Here, let me show you here.
Because I know when I read your article, I was kind of, when I looked at the end stops, because I wasn't really familiar with them, I was kind of confused on how that wouldn't interfere with the. Oh, I see.
You see how I've done that?
Oh, okay. You have it on the underneath the table.
Right. I have it underneath the table, just above there. I'm currently using it's really nothing more than a popsicle stick. With a slot cut into it so I can move that screw in and out depending where the location of the end stop a sensor is. And then I can move the adjustment for the screw up and down.
So does that popsicle stick parallel with the bridge then?
No, it can be any location. It's totally independent of where the bridge is. So you don't really need to know where this bridge is in reference to that. Because all of when you're programming this, all your references is to that 0 point underneath the bridge.
Okay.
So once the system is zeroed, and you don't really care where 0 is, because I record where the absolute position of the sensor is, because I'm using a CNC mechanism. Whoops, we lost that. Let's see if this comes back. Yeah, get a popsicle stick to hold it up.
So in layman's terms, what he's trying to say is the 0 doesn't have to coincide with, let's say, a certain position on your track. All it is when you turn this on, the stepper motor needs to know where 0 is to reference all the rest of your indexing locations when you want to line up your tracks. So
exactly right.
Theoretically anywhere, you just want to bring it back to that repeatable same 0 so that when it goes, say, 100 turns to the left, then you're at your first track, or 120 steps to the right, you're at another track. But it always has to have that same 0. So it really doesn't have to line up with a track. It's just where you start when you turn it on each time.
Exactly. It's totally independent. It doesn't matter as long as it's always there and it's never moves. You should always be able to hit back to that same place. So right now I have it in programming mode. If I want to totally start over with all my locations, I can reset it. I just type in 999 and hit pound. You'll see that it zeroed out the FRAM, and then it restarts the whole system. It's already found the 0 point because it was sitting at 0, and now I'm able to program it again. I always start with 0, and I tell it which one. I use numbers 1, 4, and 7 on the keypad. Let's see if I can show that. To move it to the left, I'm sorry, to the right. And then 7 does 1,000 steps, 4 does 100 steps, and 1 does a single step. And 9, 6, and 3 are the same, but they're the opposite. So I can move it 1,000 steps to the right or left, and then get the fine grain down to the individual step alignments.
So that's just for kind of manually indexing it.
Well, this is when where you're going to setting up your actual stub locations on your turntable as you go around. So right now I'm programming the front end of the bridge so if this is my entry track, I call that 0. My entry track into the turntable is 0. I set the front end of the bridge's location and hit pound, and then I turn it around and program the back end of the bridge's location for 0.
So do you have any buttons built in for just manually turning it? As long as you hold the button down, it moves either left or right until you release it?
No, I actually haven't done that.
Just kind of a poor man's manual indexing?
I guess I could, but I haven't really thought to do that yet. Maybe I'll have to do that later, but I haven't really thought about doing that. So I hit the last one. It sets the location and writes it to the FRAM, so it remembers that 0 front and 0 back is permanently programmed into the device, and you can always go back to it. And
does it display the number of steps for you, or do you have to go into the code then to see how many steps that turned out to be?
If I can, let's just take, let me set one more, go back into programming mode here. And it's going to 0 itself back out. And I'm just going to pick an arbitrary location here. That's basically what I'm doing right now. Let's say 99. I don't know why I picked 99, but why didn't you take it? Whoops. Okay. Well,
better write that one down.
Yeah. I have to
So
go back.
So that little chip on your Mega that you showed us is the one that you pick a location and hit program, and then it writes that location into the software.
Yeah,
you don't have to count steps and then go into your IDE and put that into your Arduino code.
No, I don't. I don't need to do that at all.
That's pretty neat.
So
I was thinking that's why you had the 1,000 steps, the 100 steps, and the 1 step, so that you could kind of count how many and then go ahead and put that number into your IDE, type it in as part of your code. But if it does it for you, you don't even care at that point, right?
Exactly right. Try to make this as simple as I can, and so that all you have to do is remember 0 to whatever number of entry and exit tracks you have into your turntable or your roundhouse, depending on how you have it set up. But yes, we can go into the software here, and if I open up the monitor now, this will restart, and it's telling me the 2 locations and the actual number of counts for front and back for the code. It will restart the home functionality, and then reset the bridge back to where its last location was. But typically, you would never go back in here to look at the serial monitor. It should be all set.
You just program in a continuously rotate command. It makes a nice little display. Oh, yeah.
Oh.
I didn't even notice that till you said that.
That's my son sitting there by his computer.
So, Johnny, do we have any questions from the panel at this point in time, or any good comments this week? Or from the... Okay. By all means, anybody out there listening on YouTube, you know, if you got any questions on this, just type them up and John will relay them to us here.
Let's see, I didn't show the my screen here from the code here.
Tunnel of Doom.
I got the mirrored effect here.
I'll just switch to your page that has the ID on it.
That's right. Do that full screen. We'll set up the serial monitor. And when the thing starts up, it goes out and it reads the RAM. And you can see right there, Chris, is your count for the front location and the count for the back location.
Oh, very nice. So if you did, yeah, so as long as you had your serial monitor open, if you really wanted to know what that number is.
Exactly. But then it sets it back to the last location there.
How many lines of code do you have in your sketch?
It's a few. Let's see. 622. A few lines there.
Yep.
And a lot of, and you know, I have a lot of print statements in there so that because I'm going through and debugging it, you know, that's the biggest challenge. When you start adding all this stuff in, especially with the LCD screen, one of the biggest challenges is that you can't really put in delays in this software. The way the stepper motor library works is that it's running through that loop over and over and over again. And if you put any delays in, you really can slow down and mess up the stepper motor stuff. So I have to work within the confines of the library I've chosen. But I chose that library because it has an acceleration and deceleration of the turntable during the process. And that's all controllable as well.
Hey guys, today's tier list is going to be looking at.
So I thought it was pretty neat when I saw this last night. If you notice, he's got 6 different libraries he's loading, you know, and that has part to do with why he had to go to a mega. He didn't need to go to a mega for the number of pins. He needed it to do for the amount of memory of the code that he's loading. The mega has more memory. So that was interesting to me. I didn't realize that, you know, still being kind of a beginner, I didn't know that difference existed. So it's kind of neat to see he's got 6 different libraries he's loading to run this, and along with all those lines of code. So
I mean, I'm using the I2C bus to control 2 of the devices. I'm using it to control the FRAM and the LCD screen here. So pins are not a limitation in this particular setup. The keyboard actually uses more pins than anything.
So you see he's actually got a key library, one that says keypad, one that says flasher, one that says Excel stepper, which would be for the stepper motor. Then Adafruit FRAM I2C Plus, that's the little chip that he had mounted on the Mega that he showed us. And then Liquid Crystal, we've used that one before. That's for the LCD display.
Correct. So
what's the flasher library for?
So That's actually, if you were to look at the motherboard or the card, I actually before wasn't going to be using an LCD panel. I was going to use LEDs, and the flasher library actually flashes the red LED when you're in programming mode, and the green LED is just to indicate that it's all set up and enabled to run, and you can switch it around. So I have those built in on the board, the custom board that I built, and then if you wanted to run it off onto a control panel or something like that, you can run a leads out for LEDs for that as well. So those got screw terminals.
Well, that's pretty cool. So how much of this is just setup versus when you get to your void loop?
Well, I define a few pins, like the max number of steps that this stepper motor is turning is 6400, so it gives you a very large resolution, so that you should be able to line up that stub pretty easily. Might have to fudge it a little bit with maybe sliding the front end of your stub points around, but I think that you shouldn't have any problems there. Then I define some startup variables. I initialize memory locations for 3 different arrays where I'm actually keeping the arrays in memory as well as in the FRAM. I read the FRAM into memory so that it keeps the speed. Initialize the liquid crystal and the I2C FRAM. And this actually is somebody else's FRAM library. They actually extended Adafruit's I2C library so that you could write strings and 16-bit words. And because we're using a number bigger than 3200 or 32,000, in some cases, that 16-bit word comes in handy. Initialize the keyboard, tell it what numbers are where, because it reads it by row and by column. And you map out the pins that it's taking care of. My custom flasher program, this is actually one of the library that I actually modified and wrote. Set up the stepper motor, what pins are controlling the actual stepper motor. Library is actually talking to the stepper motor driver, which I don't think I've shown. We can take a look at that. This is I'm going to switch back to the other screen here. So let me get back there.
Just kind of looking at that, it's like he's all the way up to line 68. He's just first hitting his void setup at line 70.
Yeah. So here's the stepper motor driver. It actually only uses 3 pins. The first 2 pins here are your power coming into the stepper motor. The 4 next sets are the actual 4 lines coming out of the stepper motor into the driver. And then 3 pins here are for controlling. These other, like the red wires, are just 5 volts to pull the second half of the driver's lines up high to enable them. I didn't feel like I needed to control the enable of the actual driver itself, so I just tied them high and automatically enables those to function correctly.
Well, that's
certainly
cool. We got a question here from Dave Piper. If you program the front, could it just rotate an additional 180 degrees? And he's got question mark steps in parentheses when selecting the back, or would it be let's see, or wouldn't it be accurate enough?
I think it depends on how, you know, it would depend on your bridge. If your bridge is 100% straight, in theory, that probably could work. But you might find that you're 1 step off or 2 steps off, and this ways allows you to, you know, to set it correctly. I just chose to do it that way. It's not a, to me, it's a one-time deal. Once I get everything set up, I just set it and forget it kind of deal.
Okay.
All right. Well, this is all amazing. I mean, you've obviously put a lot of work into this, and I think it's fair to say it's probably way over a lot of our heads, but it's really cool to see this. And, you know, I appreciate you sharing this with us. And I think what I'd like to do is just step back a little bit, kind of review some of the basics, and then have you, you know, guide us through what we could do to make us maybe think about making a simple turntable control, maybe just push button manual to start with. Because I know when I was reading into it, there's a lot of gotchas when it comes to what you would think is something very simple. It's turning a turntable. When it comes to controlling the stepper motors or whatever method you choose, there seem to be a lot of little pitfalls along the way that you have to avoid or work around. So, oh, I'm sorry. Forgot I turned that off here. There we go. So, I think what I'm going to do, let me just adjust my stuff here. I've got Greg on full screen. All right. All right, so obviously you guys are all familiar with the servos that we've played around with, and that is literally one way you could run a turntable if you wanted to, but you're going to be limited to 180 degrees of travel, actually a little bit less. If you remember, oh, it was probably a year ago when we talked about that, but a lot of these little 9-gram servos literally only go about 170 degrees. They don't even do a full 180 degrees like people tend to think. So you wouldn't even really be able to rotate a turntable halfway around. If you don't want to turn your locomotives, that would be fine. But if you really wanted to use it to turn locomotives, you know, using a servo is really out of the question. I mean, you could use it to just drive on, move to that track and go into the roundhouse, or move to this track and go to the roundhouse, etc. But then when it came to it, you'd have to back off the turntable again and find a different way to turn your locomotive. But it would be, you know, fairly simple with a servo to do that. I think when it came to actual precision alignment, though, you know, it would probably be not real difficult to set the indexing and the programming, but then you'd probably have to do a little fine tuning, because the servos don't seem to have quite the repeatable accuracy that a stepper motor would have, especially the cheaper servos. Now there is another option. They do make servos that rotate 360 degrees, and I think they'll turn continuously too. I've never had one to experiment with, but I do believe you can continually rotate a 360 degree servo, so that might be another option.
I have seen those, and yeah, they do go 360 degrees. They use them for motor drivers, for robots and things like that. So right. I mean, they do make them.
Can they continue on in the same direction and go, say, 720 degrees?
I don't know if you have the feedback, though.
No.
Because, you know, in the stepper motor you have there is actually a resistor in there, a resistor pot that it's actually reading. And so I think depending on how accurate that is, I don't know if it'll come back directly to the same location every single time.
I would also be worried about the weight on the servo too.
Well,
I don't think the steppers are. I'm sorry, the servos are as strong as a stepper motor, as far as torque's concerned.
If you bought a bigger servo, if you use these little 9-gram servos, you know, depending on what your mechanism was between this and the turntable. But I know you can definitely get bigger servos with a lot more torque. They're going to cost you a lot more money, though. You're not going to get them for $2.
Yeah, but your precision is not as great as with a stepper, though. That's
correct.
That's the thing.
So I'm just, you know, kind of exploring a poor man's option if you really wanted to just play around with it. Like, you could do like Greg did and start out with just popsicle sticks to test your theory, you know. That was really cool. I remember when he had that popsicle stick model on here on a previous show. Kind of. So once we go past the servo, obviously, you know, the stepper motor was the next logical thing, and that's what Greg is using. And I'm not sure exactly which motor is, but remember we were goofing around with this little one that came in our kits. It's kind of a neat little motor, but it also has its limitations. Of course, you need the servo motor driver to run it, but you know, one of the things I found out about these was the repeatable accuracy. This is basically a 64 degree, I think it was, is what they call it. But in reality, it's like 63.49 or something like that. So what happens is if you would start your turntable and index it and then never turn it off, so you didn't have to re-home it to 0 like Greg was showing earlier, what happens is eventually you lose that half a degree, and pretty soon, you know, after maybe 50 cycles or something like that, you're no longer lining up with where you need to line up. So that's one of the benefits of having to home it. But that's one of the bad things of a servo, or I mean of a stepper versus a servo. When you turn on a servo, it always knows where 0 is. So whatever, if you want it to go how many steps to the left or how many steps to the right, it's always going to go there. A stepper motor does not know where 0 is when you turn it on. So that's why Greg created that really nice system to show and create a 0 point for it. So that's, you know, kind of the theory behind why you have to do that. But once you actually have it 0, then it can count the steps in any direction and go exactly where you tell it to go, but it doesn't know where to base that off of if you don't 0 it first. Well, that's just kind of a little comparison of why I would use a stepper versus a servo, or vice versa. Depends on what your end goal is. Excuse me. And speaking of steppers, I just want to show you guys a little something. I was cleaning out the basement the other day, and I have about 3 old printers at least. Just going to throw out, and it's like, you know what, before I throw those out, I'm going to tear them apart and see what's in them. And I started finding stepper motors like you wouldn't believe, and gears to go with them. So it's kind of a poor man's way to get some nice stepper motors and maybe some gears if you want to start building a little turntable. See, this one's got the little gears right on it. And we'll put this up higher, maybe then you can see more of it at once. Oh, it looked good on my screen. I didn't realize it wasn't focusing. I apologize for that. But, one of the neat things was even these little, as you can see, I'm just swimming in parts here. These little gear belts and sprockets or gears to go with it. So if you wanted to, you know, this one actually still has the gear on. Well, all of them still have the gear on it, but you know, if you're looking for something to play around with, go tear apart a printer and find, you know, I've got just a whole pile of them here. I think 6 or 7 of them I got out of 3 printers. So, and a bunch of little gears and stuff I took along with it. So the other thing I found, not related, but there were a bunch of big capacitors I was able to desolder from the motherboards that might be able to use for keep alives or something like that. So there's a lot of cool little parts in there if you want to salvage them and desolder them. So in fact, I never thought about it till just now, but there were actually the nice polished shafts too that you could use actually for your main turntable shaft. There's 2 of those in each printer too that the cartridge slides back and forth on. So anyways, Where are we at time-wise, Johnny?
40 minutes.
Okay. So I'm thinking what we can do now is, Greg, if you want to jump in now and join me, let's walk through a very simple, let's say we were going to start with a stepper motor, and we could pretend it's a cheap one like this or a better one like you use. But let's say we wanted to just create a very simple, I have 2 push buttons. If I hit one button, it rotates to the left. If I hit another button, it rotates to the right. That would be about the simplest turntable you could build. And I think that would be fairly easy to program. You wouldn't even need to worry about zero, because you just turn it on and you're going to manually push a button one way or the other and stop it when you get to where you want to stop it.
Yeah, I think you need to go back one step and look at the driver for the stepper mode.
All right.
I think you need to go back one step and go and look at the driver. Your driver actually tells you how many steps that stepper motor is going to make. So in mine, it's programmable. I chose the highest resolution to 6,400 steps. I think that's the very first part. If you want to make a really, simple turntable, you need a really good driver, no matter what stepper motor you're going to use, to give you that resolution. And then we could just use 2 buttons, like you said, and tell it to step off.
The next improvement on that would be another set of buttons, because the problem with 2 buttons is when you get just to where you want to line your 2 tracks up, you want to be going fairly slow. You don't want it jumping. But in order to go fairly slow with just 2 buttons, you're going to be going slow the entire way until you get there. So the next improvement would be a pair of buttons for fast to get close, or even just overshoot a little, and then another set of buttons for the slow fine-tune adjustment. So then you're going to start to add a little bit more programming, but not a whole lot. You just duplicate what you had and change the speed. I think would probably suffice for that. But this is where Greg, having actually worked with it, can fill us in with the details on that.
Maybe a better option would be to use a rotary optical encoder. You turn it one way, the bridge turns one way. Turn it the other way, it turns it the other way, and you could, faster you turn it, the faster it's going to spin, and you can slow it down and tweak it in. That might be an easier way to use a single control.
Okay, and so for those of you who might be wondering, a rotary optical encoder is just a dial switch that actually does the same thing a stepper motor does. It'll count the steps, so it's very precise. But what he's saying is, you turn that knob, the faster you turn it, the faster it'll go, and the slower you turn it, the slower it'll go. So it'll match not only speed but a precise location.
You can set it up to even know which direction you are, so you could actually switch it back and forth depending on which way you wanted to turn it.
If you any of you guys who own NCE, you know that on the main cab they have a little roller on there for a throttle as part of the throttle. That's a rotary encoder.
Or your volume control on your radio in the car. You can just spin those around.
Yeah. So in order to do something as simple as that, I think all you'd really need is besides the mechanism, and I don't think, we kind of beyond this show to get into what you use for the actual mechanicals of the turntable. We're kind of concentrating on the Arduino control portion of it, but I think beyond a stepper motor and a stepper motor driver, the next thing would be just the programming, right? I mean, is there anything else? No, and the Arduino, of course.
Yep.
Is there anything else? And push buttons?
I mean, you could use a keypad like I did and hook up like 147, turn it one direction, and 369, and that gives you your resolution. And for you know, how many steps you want to set it up one way or the other, or you could do the encoder, or you could do unique individual buttons. I mean, either way would be fine, and then you build off of that.
Yeah, you could kind of do it like we did the speedometer. You start with the simplest thing, and then just, okay, what do I really need next, and add something to it, and then just keep adding something to it or improving it. You know, go from a digital display to an LCD display. Go from a cheap keypad to a good keypad, or go from push buttons to a keypad. You know, there's ways to incrementally improve it, but you always have a working model, but then you're continuing to improve it. And if that's something that the audience is really interested in, we could take that up as a show. Actually do the heads down building of one and do the programming of it and come up with a kind of a working model. But I think there's so many variables and everybody wants to do it a little different. I think the best thing we can do is just get the basics out there for you and have you start experimenting, and then maybe have a show where if somebody has a problem, we could help them troubleshoot it or something like that. But I just think it's kind of the more I read into it, the more complicated it was getting to the point where I think it was a little beyond, you know, doing an actual build it on the show type project. So, well,
I'm not a programmer in general. I call myself a hacker programmer, because I believe in the statement that if somebody has made it on the internet and they freely make it available, don't try to reinvent the wheel, especially if it works for you. So I looked at a lot of different applications out there, i.e. the driver, the FRAM library. You know, this is what I want to do. Does somebody have it out there? Than to try to go out and program it for myself. And that's why I chose those individual libraries to incorporate in my project. And then I just worked on one area at a time. Like you said, you know, get this section working. And it wasn't intuitive right away with the stepper motor library. How do you make that work? How do you start it up and actually zero out the stepper motor library every single time you need to zero it out? It's not intuitive necessarily in the code. It took a while, and other people online were having the same kind of problem, and I finally found the right thread that I was reading through to make it work. So you take it in baby steps, and that's how I got this one working. The same, like hardware-wise, I had to make modifications to the hardware as I got going, because I picked a certain stepper motor, and I found out that the drivers that I was using was burning up because of it. I mean, it was just way too hot, and that's why I picked the little bigger stepper motor driver. This driver, Chris R, you probably could use for your bigger turntable that you were talking about earlier. Because it can handle up to a 4 amp stepper motor.
Yeah, that's what I was going to use because of, you know, based on your article in the EMAG, I build mine a little different, I think, but the concept's the same. I don't know on how if I'm gonna use the framer or not, or how I'm gonna do that. I haven't decided. I'm pondering that, but definitely I'm gonna use that driver, the bigger NEMA stepper, and the end stop. I like how you put that underneath the bench work like that. That's a good idea.
Yeah, you don't want something to run into it.
No, and I actually thought about using a magnetic hall sensor. And put a little magnet on the bridge so that the stepper, you know, the Arduino would pick up where the bridge is, per se, by that little magnet. But using the end stop, I can see where the end stop would be a bit more precise because it's used for 3D printers, for example.
Yeah, and I just needed something that would be repeatable over and over and over again, and it seems like that works really well.
Yeah, that was one of the key themes. Everything I was reading about with turntables and the indexing was the repeatable accuracy. You know, that's where that's the money shot. If you find a way to do the repeatable accuracy, and that's where maybe in the beginning you want to just do a manually operated one where you're pushing buttons or turning an encoder, because that's where it gets difficult, is trying to do that repeatable accuracy to always stop those tracks lined up perfect every time.
Exactly.
Got a comment. This is from Tab, Maryland. When we were talking, y'all were talking about the resistive knobs and all. He said a resistive joystick might make a nice variable speed control input too.
Yeah, that could be fun. Actually, just grab one. I was talking about is just pull that out of my kit. Got one of those with the kit that I bought, so it's literally just put the knob on here, and you know, it's typical like a game type joystick, but I'm sure there's plenty more out there. This is just a cheap one, but yeah, you could just go left and right and slow it down, speed it up. All you would need, I'm assuming there's probably a library. I haven't actually used this. For, if you guys want, I could come up with a project for using this. Maybe just turning one of these. That might be a little way to get started. So yeah, that's a great idea. You know, instead of a couple of buttons, you just hook this up instead.
Is that an I2C one? It makes it simpler.
Yeah, it appears to be. Ground 5 volts, VRX, VRY, and SW. That's the 5 pins on there. So we got an X and a Y. I'm sure for you know, axes. But I wonder if this pushes down too. I should try that. Oh yeah, it does. It's also got a. It's also, can you actually see it? Right here is a little micro switch, and when I push down, you see that. So it'd actually be just like your little PlayStation or Xbox. When you push down, it also has a click function. So looks like there's possibly a little potentiometer. Oh no, that's part of the. I was looking on this end of it here. Looked like it may have been a potentiometer, but it's not. It's just part of the mechanism for doing that. So, yeah, that'd be something fun to try. Because yeah, it's just, you know, the difference between going from, like I say, push buttons or even a joystick to having automatic indexing. That's where the difficulty lies. That's where you're gonna, you know, increase how complicated or how difficult it becomes as you go. So, you know, obviously, if you're talented like Greg, and I know Chris Rude, dang talented too when it comes to this stuff, that shouldn't be a problem. But for somebody like me, I'm gonna put a lot of time into something like that. You know, I know the basics, but I don't know. When I looked at his code, there's a lot of stuff in there I hadn't seen before. So,
yeah, Dave Elkins, since we mentioned the joystick, he's saying use X-axis for fast and Y-axis for slow speed.
There you go.
Yeah. Okay.
Or the
farther,
farther you turn right or left, the faster it goes.
Or even, you know, similar to a RC airplane. Okay, you've got combinations of up and left, the farther up and the farther, you know, almost like an airbrush trigger, a 2-stage airbrush trigger with 2 directions to it though. So farther up and farther left would be faster in one direction, slower, faster, but still the same direction. Switch to the other side, faster, slower.
There's a lot of good examples on those joysticks too, because a lot of people in the and I'm going to quote unquote makerspace use them for their projects. Adafruit has a couple of tutorials on them. I was looking at it because I'm working on another project that I was thinking about incorporating a little joystick on, and I was reading about them. They're very simple, but going back to what Chris was saying is, you know, with any of this stuff, and I'm sure Greg will agree with me because of his project, but you always start you do it. You consider it like building blocks. So you take a little piece, you do it, you get that working, then you add your next block, and you just keep doing that until you get what Greg's got. With that being said, for example, you may want to play with the LCD. You get the LCD working. You may not want to work in that order, but it's an easier thing than maybe dealing with the stepper motor, because there's a lot of math with the stepper motor. So you get those little pieces working, and you just do versions of your code. If you notice with Greg, he's at version 1.5. So I'm sure he was at version 0.1 before, So I recommend that to everybody that asks me about stuff like this when we're in the nightly chats or whatever. I said, just start small. Make an LED go on and off. Once you get that, then make a servo turn as part of your code or whatever you're doing. It's and then that'll just build it for you.
Even like the speedometer, if you go back to when we built that, I remember we did 5 or 6 versions from very simple to the time, by the time we were done, we had a bi-directional with LCD readout, where we started out with a single direction 2-digit LED display. We just kept incrementally making it better and always having a working version, but improving it.
Mm-hmm.
So you can take both of those approaches. You can start with a complicated project and do it a piece at a time, or you can build a simple version of that project and continue to make it better and improve it. So you have both of those are actually 2 different avenues that you could approach.
All right.
I mean, the biggest challenge I was having was, how do I figure out when to restart this thing? Because if you look at how the stepper motor library is set up, it's for writing running a CNC thing. So it's not designed for making a circle go end to end. It's straight out, straight back. And it took me like 3 months to figure out where can I re-zero it to make it 365 or 360-degree circle. Well, that's 0 to 640, but I need to reset it, but I need to read past it. And it took me like 3 months to figure that all out in my head. But by that, I mean, that wasn't the only thing I was working on. I got it up and running in the basic functions, and then as those harder areas, I worked harder on those. So, like you said, take baby chunks, work on it that way, and you can get a good project going.
Okay, and then the $1 million question. You ready?
Yeah.
When you have it done, and as Dave asked about, sharing your prototype board, what about sharing the code eventually? Is it something you're going to put out in the public domain once you have it, you're happy with it, and you clean it up?
That's what I'm thinking I'm going to be doing. I might be, I haven't, my family keeps saying, well, are you going to sell the boards? Are you going to sell the boards? And I might do that. I haven't decided one way or the other. But the code uses public domain code, so I don't feel like I could ever sell the code without paying royalties to those other vendors that have created the library, especially the stepper motor library and things like that. So putting it out in the public domain seems to make sense.
All right. Well, anybody have any other questions, or I think we do have a little time left, Johnny, or is it going up on?
Yeah, we're at 59, so yeah, we haven't got any more comments.
Okay. I guess the only thing I really wanted to talk about yet was, going into next year. I've got a couple different ways I'm thinking we can go with this show. I know we're kind of getting beyond the hands-on working, and one of the reasons for that is we've gotten beyond the context of the show. We started out, for beginners by beginner. I was a beginner a year ago. I'm a little bit better than beginner, not a whole lot yet anymore, but obviously all of us that have been working along know a whole lot more than we did a year ago. So do we want to, in order to keep this show by beginners for beginners, I almost have to go back up and start over and rework through the material we had, because I think we've kind of ran out of material for keeping it in a model railroad context. The other thing we could do is we could start to go make this a more advanced show. And I'd love to be able to do show and tell projects like this, because I learned a lot tonight and talking to Greg the last 2 nights, and just from seeing what he's done. Even though I may never build it, I've learned a lot from it, and I'm hoping that's what's happening, with this show in general. I know Chris has got some cool stuff, Andy, and still love to be able to get like Steve Spence or Massacre on this show to show off some of their cool stuff. So we could, we could turn it into maybe a show and tell show, or just another thought I was kicking around was just cool model railroad electronics in general. We could break away from Arduino and start to talk about, Raspberry Pi or any other cool things. Electronic, kind of an electronic what's neat, you know what I mean? Not necessarily to rehash old stuff that's out there, but to kind of stay on the forefront of cool stuff that's coming out. There's just some of the ideas I'm kicking around, and if you have any comments on that, please go to the YouTube, Google Plus page, I should say, or in the comments of this video, or even on the Facebook page. I'd like to get some feedback on the direction you guys would like to see this show go, or keep on the same direction we're on right now. So other than that, I think I'm pretty good for tonight. Anybody else have anything? Dave?
I would just say that if you're gonna, and maybe we mentioned it before, and I think I mentioned it in the EMAG in my articles or whatever, but if you want to do this stuff and learn about this stuff, just go follow the Arduino stuff, the makerspace stuff, because even though people are doing projects that aren't for model railroading, you can kind of use your imagination how you can apply it to model railroading. Like Dave said, or Greg said, I'm sorry, that like his stepper, just say the stepper motor or whatever. He didn't learn that because he went to a model railroading website. He had to dig through people who are building DIY 3D printers or whatever. So there's places like Adafruit. There's tons of YouTube channels. The Arduino Create community that Chris showed last show. There's tons of resources that you could use to kind of build what you want per se, but you kind of have to kind of go around an indirect way to doing it.
Yeah. Well, if I kind of dropped that, and that was a self-imposed that should be model railroad related, that's one of the reasons we haven't done this, as well as a couple other things in the kit that I bought, just because I couldn't come up with a real practical application for this. I didn't spend a lot of time, but maybe thinking about what you just said, there's a lot of these little boards and gizmos out there. You go out on Amazon or eBay or Banggood, there's just hundreds of little peripherals for controlling Arduinos. Maybe we go look at a bunch of those, buy them and test them out and see. And like you said, maybe it'll crack an idea that could be carried over into model railroading.
And I think the other thing is, don't be afraid to fail, because I certainly picked the wrong hardware. Don't let that be a showstopper for you. Ask questions. People here on the YouTube channel would be more than happy to help you. I'd be more than happy to answer any questions you guys have. So I'm not perfect, but I can certainly try.
Yeah, that's kind of the whole premise of this show. We're all trying to learn together. None of us are, necessarily an expert. We share what we learn as we go. Try and help everybody.
Even if you have more experience doing it, you're still learning.
Exactly.
Right. You never stop learning, otherwise you might as well start throwing dirt on yourself.
Exactly. I totally agree with that.
I never would have thought I'd run out of memory, but I did on the Uno. So I mean,
yeah, that alone, like I said, I was totally unaware that the Mega had more memory. I thought it just had more pins. I suppose it makes sense. in order to have more pins, more memory. So
I mean, the Mega has a lot of options. I mean, it has like, I think 2 more transmit channels and everything on it. So I mean, you can do a lot with an Omega that you can't do with an Uno.
You want to see a mini Mega?
a mini Mega.
A mini Mega.
I've seen one on TV, or I should say on YouTube.
I can find them.
Is that like a Mega Nano?
Yeah, you saw. I've shown this to you before, Chris. The Mega Pro. It's like an Uno Pro Mini, but it's a Mega.
Okay, I mean, I must have forgot about it then if you did, but
That's a Mega. It's the same thing as what Greg's using, except that it's totally tiny and can fit on a breadboard or your own board.
Yeah, that's the same thing.
Yeah.
got a box here. Wait a second here.
I have a project.
Except that those are kind of expensive.
I think I paid $5 for this.
Seriously, I've never seen one that cheap.
Yeah, I got it off AliExpress, I believe. Yeah. I got it. Came right from China. It might be expensive in China, but not here in America.
Yeah, so this is, I finally went out and managed to, I bought 3 of these are the Nano. I bought the Nano because it already has the USB on it. Then I also found these little terminal block adapters, if you will. And the reason I bought these, and you got to solder it all together. Unfortunately, it's a bunch of little pieces, but at the end of the day, your Nano sits on top of it, and then you've got screw terminals like this lined up down both sides. So basically, the Nano sits on there, and then you've got, instead of pins and jumpers, the reason I bought this is I actually put my first Arduino into production on my model railroad. I've got one of these controlling a servo and 8 LEDs, you know, to control a passing siding. So it turned out pretty well. I didn't build the other 2 yet, but you know, like I said, there's kind of tons of neat little stuff like that. We could go out on eBay and find and just build stuff. That's cool that, you know, what Chris was just showing us too. So, you know, it might be a way we could go with this show. But see, at the end of the day, these will all be soldered on here, and you, not straighter than that, obviously. And you've got a nice little proto, you know, put it into production and still be able to change your wiring because you're not soldering to it. Like when you're hooking up the LEDs for the signals, I had no way of knowing which wire was which until I actually hooked it up. Well, you don't want to solder it and have to desolder it when you find out you hooked it up backwards. So the little screw terminals are really nice for that. That's cool.
This is my first stepper board, or stepper controller board, but I definitely overheated. Each one of these little squares is a stepper motor controller, so you could do actually up to 3 on this one. So if you use the smaller one, you could use this. And it just plugs right into your Uno.
Nice. All right. Anything else? Brother Dave or Chris?
I suppose I think I share my piece.
All right. All right, Johnny. Good talking to you guys, and all Merry Christmas, Happy New Year, Happy Hanukkah, whatever else would be appropriate for you. And nothing else. We'll see you after the New Year on the January show.
And to you.
Johnny.
All righty. I want to say go back to YouTubeModelBuilders.com. There you can find the schedules for the Tuesday and Wednesday shows. Those are at 8 o'clock Central, 9 o'clock Eastern Time. Also, Thursday and the Saturday show are at 9 o'clock Central, 10 o'clock Eastern Time. Be sure and click on the eMag while you're there and sign up so you'll get an email notification when the eMag comes out. November was dedicated to N scale, being it started with N. And let's see what we got for this month. All right, our next show will be the Thursday night general hangout tomorrow night. Next week we have December the 12th will be Miles Hale's show. Then we also have December the 14th, the Fine Scale show. Yes, I know that's a Thursday, but December, you got the holidays, people traveling, so kind of had to rearrange the shows a little bit. So Fine Scale is going to be on Thursday night this month, and it still will be at 8 o'clock Central, 9 o'clock Eastern time. It'll stay in the same time slot. And then December the 16th, we have the live show with Bill and Barry. That will be at 9 o'clock Central, 10 o'clock Eastern time. So the only real change right now for next week will be the Fine Scale show. Will be on December the 14th, which is a Thursday. So be sure to make note of that. It's also in the schedule on the website too. So, and if you have ideas for the show, be sure and put them in the comments, either in Facebook or YouTube, so Chris can pick them up and see what people are wanting to see on the show. I want to say thank you for coming in and watching tonight. Chris, thank you for another good show. Greg, appreciate you being on the show. Dave, Chris, Rude, appreciate y'all coming in on the panel. So we'll see you tomorrow night on the Johnny Mall Train Talk Show. So y'all have a good evening.